Greetings. I'm Jeff Walton, the Executive Director of the American Association of Christian Schools. And this workshop is Improving Performance in Mathematics, grades 4 through 8, using the Iowa assessments. The focus of what we're going to talk about is grades 4 through 8. I think that there's application to grades below that and above that. But most significantly, what we'll talk about addresses some issues observed through analysis of Iowa results for AACS students in grades 4, 5, and 6, with some easy carryover application to grades 7 and 8. There are two related workshops as part of this convention. One is Reading Between the Lines, that looks at improving reading comprehension scores for our students. And then a workshop that precedes this one that's about analyzing reports for identifying content areas where we need to improve as a school. So that workshop is a workshop that I did, and in that workshop I illustrated using the process that we used to analyze AACS reports for the 50,000 plus students that participated in the AACS program in 2015, 16, 17, and 18. I think I got off a year in that, 16 to 19. And I'm not going to go through all of that workshop. I want to encourage you to watch that if you haven't already. But I'm going to touch on just a couple of things from the content of that workshop to get us started with this one. The first of those is this slide. Why do we take standardized tests? We take standardized tests for a number of reasons, but top among them are measuring student learning against the performance of a broad group of students. We want to know if our students are learning the things that students in their grade across the country are learning. And we want to identify relative strengths and weaknesses in our program. So are our students performing strongly in math and English language arts and history and science, or are there some areas where we're not performing strongly against national norms, and some evaluation that we need to do about why we might not be doing as well. It's also important then that we understand some things about test construction and norm setting as background for what we're going to talk about. For the Iowa assessments, and this would be the time-tested method for determining what will be on a standardized test. The standards are determined by comparing state standards, international standards, textbook content, and identifying common themes. So in short, the process that Iowa test constructors would go through is to collect state standards from a number of states with significant student populations, map those out for math or English language arts or another discipline, collect textbooks from several major publishers and map out the core content or standards for those textbooks, international standards. And then having mapped all those out, then they look for the common threads, the things that are commonly taught in various states and across textbooks, and those become the standards for the creation of the Iowa assessment for that grade and that discipline. That is the method that's been used by test publishers, standardized test publishers, for decades, and is one of the significant reasons why we selected the Iowa in our test selection process in 2014 and 2015. So that's significant to understand. And then also, the norms for the Iowa represent 575,000 students, approximately 48,000 at each grade level, 89% of them from public schools. So it's a really large group of students from which the norms are derived. And it's a very carefully selected group of students to represent public school, private school. So you're getting a good comparison to a national sample. So taking those things together, when our students score below the national average, below the 50th percentile on a subtest, or below the national average on a test item, we know that they haven't mastered a commonly learned skill or some content that most kids their age know. It's coming from this process of evaluating a wide range of standards, looking for the common threads, and testing a large group of students, finding average performance on test items and subtests. So if I find that my students are missing from their experience a piece of content or a skill, or are not performing as well as their peers nationally in an assessment related to that content or skill, if I decide to teach that skill or content, it's not just that I am trying to improve test scores. We administered the test in part to identify those missing pieces in our course of study. So I'm using that data that I've learned from that analysis to improve the learning experience at our school. In the AACS office, over about a year, we looked at test scores for students across the Iowa program in AACS. We didn't take a year's worth of staff time to do that, but over a period of several months, we evaluated different pieces of this. And we determined that the typical student in an AACS member school is performing significantly above national averages, above national norms, except for 3 grades, upper elementary grades, 4, 5, and 6. And at those grades, our average student scores drop from somewhere in the 60s. When you test a really large group of students, you would expect scores to cluster right around the norm. The larger the group is, the closer the scores tend to cluster at the 50th percentile, or the exact average or norm for the group. But in AACS schools, we typically see a higher performance. Most of our average student scores for a grade are above the 60th percentile, many of them between the 60th and 70th, some of them above the 70th percentile, which is really exceptional for large groups of students. But at grades 4, 5, and 6, they were in some cases below the national average, particularly on some subtests. And those subtests are dragging all of those scores down at those grades. So we did some analysis, like the analysis that would be described in the process that I did in the last workshop. The last workshop dealt with this question: how do I identify areas of low performance? And I'm not going to rehash that workshop, but I do want to put a teaser in for it if you haven't watched it yet, or suggest that there is a similar recorded webinar on the AACS website. Judy Lynn and I did webinars on this topic about a year ago, recorded them, and they are available on the AACS website under the Services tab and then the Convention Resources tab. They're not going to be identical to what we're doing here for the California Convention, but they would be very similar if you would want to access one of those instead. So you would go through that process of producing reports and analyzing data for your students. When we did that for AACS students, we found significant weaknesses in math concepts and in reading comprehension for AACS. What do we learn about math concepts from that domain and item analysis for grades 4 through 6? We learned first that computation is not our problem. We perform very strongly on all of the subtests related to the mechanics of math computation. Same thing with reading mechanics. We do well in those areas, but not as well. In fact, sometimes by pretty significant numbers, we're below national norms in some math conceptual understandings. Here's what our kids don't know based on this analysis of the reports and then a comparison of those to the test documents. I've listed these in the order of significance. So what that means is the first items are the items that are missed by the more significant numbers of our students. So if we're going to fix weak areas for AACS as a whole, we would address them in this order. You are going to have to look at your individual school reports for this, because this weakness for AACS may not be a weakness for your school. And you certainly don't need to invest time and teacher resources in improving an area that's not an area of low performance for you. But it likely is, because it is an area of low performance for AACS as a whole. I'm going to list the more significant areas, and then we're going to go back and take them one at a time with some suggestions for remediation and improvement in those areas. The first is some types of data display: scatter plots, stem and leaf plots, and box and whisker plots. If those don't sound familiar to you, your school is probably in the list of schools where some improvement could be made on the student experience that would be reflected in improved test scores. Simple probability ratios. This would be probability involving things like colored marbles or the numbers on dice. Symmetry, reflections, and translations. Those are the math terms. They won't use those terms in the problems for fourth graders or fifth graders or sixth graders, but those are the concepts that our students are not understanding. They're not recognizing symmetrical figures or reflections of figures or translations of figures. Some terms, they're missing problems where the term mean or least common multiple or greatest common factor is used. Logical calculations of area and volume. We seem to be pretty good at applying formulas. So if the formula or if the figure can be calculated with a common formula, we do pretty well. But if it's an irregular figure that can't be calculated simply with a formula, our students don't do very well in those problems. Place value with understanding. In most of math textbooks today, there's a really significant emphasis on place value and understanding place value. You might argue about the value of that for students at grades 4, 5, or 6. I don't think I would argue about the value of that. I think there's really important value to students understanding place value. But it is something that kids commonly know at those grades, and that they know in ways that are more advanced than students in AACS generally know. Order of operations and symbols of inclusion. Simple algebraic equations and models. Just that expression sounds confusing to many elementary teachers, but we'll illustrate it, and I think you will say, oh, is that all that is? So what can we do about it? Those are the areas. Now we're going to go back through and address them one at a time with some ideas about how you might improve instruction. I almost titled this workshop Colored Marbles, Sugar Cubes, Graph Paper, and Paper Folding, because many of the things we're going to talk about could be taught with those simple tools to illustrate for students and help with their understanding. Significant improvements could be made by incorporating a few hours of supplemental activities each year, beginning with grade 4. So what I'm going to suggest to you is that if you're a typical AACS school in math, you could really improve your student understanding. In doing so, you would be teaching them content and skills that other students are commonly taught across the country. And you could do that with some supplemental activities. Sometimes when we start evaluating, analyzing assessment results, the first thought of teachers or school leaders is, well, we need to change our textbook. Maybe there might be a textbook that's a better source for you, but it's more likely that you can supplement the content of your textbook, or find out that you've actually been skipping content in your textbook that you should have been emphasizing if you were going to help your students. So taking these topics in order, what do we do about data display? I, again, want to note that I've done these in order of significance. So the area in grades 4, 5, and 6 where the most questions are missed by our students is in this area. Some types of data display that not all of our students are familiar with. Those types of data display are box and whisker plots, stem and leaf plots, and scatter plots. If those are not part of the curriculum for your students at grades 4, 5, and 6, then they are likely missing those questions. This is really significant because these are the kinds of problems in math where on a standardized test, one problem will be presented and then often 2 or 3 questions will be asked from that one problem. Well, if that problem has to do with a stem and leaf plot, and the student is unfamiliar with a stem and leaf plot, then she's going to miss all 3 questions about a stem and leaf plot. And on a typical subtest, on any standardized achievement test, 3 questions is generally 10 percentile points, somewhere in that area. Might be a little below that, a little above that, but it's a pretty significant number of points. So there are a lot of students in the AACS schools that are missing 3 questions on a math subtest, dropping their score by 10 percentile points because they don't understand one of these types of data representation. In visiting schools last fall, I asked to see their math textbooks for grades 4, 5, and 6. I reviewed the textbooks from 5 different publishers that are used at AACS member schools. 3 of those publishers covered all 3 of these data displays in grades 4, 5, and 6, not necessarily at the same grade, but they covered all 3 types in grades 4, 5, and 6. One of them covered 2 of the 3, and one of them covered none of the 3. So I encourage you to look at your textbooks, see if these are covered. If they're not covered, I encourage you to think very seriously about some supplemental lessons to address them because they're affecting student scores in significant ways. But more importantly, your students are not learning something that other students across the country generally are learning. You could make a good argument that students don't really need to learn these things, that they don't really need to learn a box and whisker plot or a stem and leaf plot. I think you could make a legitimate argument that they don't need to learn those things. But you cannot make the argument that learning these things is non-Christian in some way. I don't even think you could make the argument that it is progressive in some way. It is somewhat new content that was not a common data display type in textbooks 30 or 40 or 50 years ago. But I don't think you can make a good argument for not learning these types of data display from a Christian worldview standpoint. Now, you might from a mathematic readiness standpoint, whether or not kids are developmentally ready to understand everything. This is part of especially a box and whisker plot. But we do know from the data from test analysis that our kids do not know and cannot do problems related to these at the same level that their peers can across the country. Other kids can do it, but many of the kids in our schools cannot. Now, how would you supplement these? How would you learn about them? I'm going to suggest 2 resources for you. I did look on the Khan Academy videos to see if there were good videos that you could use to supplement in your classroom. I didn't find any that would be appropriate to 4th, 5th, and 6th graders. I found a number that would be appropriate to secondary students so they would help you as a teacher understand them. But the lessons themselves I felt were over the head of 4th, 5th, and 6th graders. And so I devised 3 lesson plans that are on a level that I believe can be understood by 4th, 5th, and 6th graders, can be used by teachers in 4th, 5th, and 6th grade classrooms, and that would introduce each of these kinds of data display to your students at an age-appropriate level. It's only one lesson on each of them, but I think from that one lesson, you would be able to derive enough understanding that you could develop other lessons if you would choose to, or you can find scores of lessons on Teachers Pay Teachers. Those lesson plans are housed on the AACS website. They're under the Services tab, and then Convention Resources, or the teacherspayteachers.com is also another resource for that. The next 3 slides show those kinds of data displays. Not going to talk about them except to demonstrate them for you, but those lesson plans would give you tools that you could use to supplement what you're teaching if they're not already part of your curriculum, and teach them to your students. So box and whisker plot is illustrated there. A stem and leaf plot is illustrated here, and then a scatter plot is illustrated here. Most of you will be familiar with the scatter plot. Some of you may be not very familiar with the box and whisker plot or the stem and leaf plot. But again, I encourage you to consider either teaching those from your text. Some of you might be skipping them, or adding them as supplementary material for the instruction of your students. The next area is simple probability ratios. A lot of our students miss the problems related to simple probability, and those can be easily addressed in a fun way with your students by adding student activities and games that use colored marbles and dice. The problems are going to be very simple. They're going to be something like, from a bowl that contains 3 red marbles and 5 blue marbles, a student draws 1 marble. What's the probability that he has drawn a blue marble? So they'll be very simple problems, and you can teach those to your students in an activity where they blindly draw marbles or they roll dice to see how consistently their actual experience matches the probability ratios that they determine from evaluating those dice or those marbles. So I'm not going to teach that lesson to you, but there's a real easy resource for you to use. And again, a lot of information about that if you want to do a web search on teaching probability ratios to elementary students, or teaching probability ratios using marbles or dice, and lesson plans available on Teachers Pay Teachers. What can we do about symmetry, reflections, and translations? Again, those words won't be used in the test documents, but they will ask students questions about what happens when you flip a figure across this line, which would be an illustration of a reflection. What happens if you pick up and move this figure from one side of the line to the other, which would be an illustration of a translation? What happens if you fold this figure right in the middle, which would be an application of the ideas of symmetry? You can do a lot of really neat things to teach kids these concepts using paper folding activities. So you would define the terms that you need to know. I would be all in favor of introducing elementary kids to these terms, to symmetry, reflection, and translation. Many of your kids will grasp it right away. It's just the definition of a new term. Some of them may not grasp it, but they will grasp the concept and then be able to apply the concept when they see it on a standardized test. I'm going to show you some illustrations of some paper folding activities. I have them in a different document, and there's not a real easy way in Adobe to switch between documents. So there are a couple of illustrations that I'm going to show you after we finish our slide presentation. You can also do activities on graph paper of symmetry, reflections, and translation. So you could illustrate them on a graph on your whiteboard or on a digital device, and then have students draw on graph paper reflected, rotated, and translated figures around lines of symmetry. they would enjoy doing that. There are some really neat paper folding activities at a website that I will also show to you at the end of this presentation. What do we do about problems that involve mean, median, least common multiple, and greatest common factor? I don't know any games to help you with this one. These are just terms that kids have to learn and processes that they have to learn to follow. I did not see a fourth, fifth, or sixth math textbook that did not include these things in the 5 that I evaluated. So they are there for most of our students, and doing better in problems related to these is probably primarily an issue of spending a little more time with them, helping them understand the terms and then be able to do problems that involve finding the least common multiple or the greatest common factor with simple sets of numbers. The sets of numbers that they use in these problems are not difficult at all for students to work with. And again, from your own item analysis reports and comparison to the test documents, you can see if this is an area where your students have problems and you should spend some more time on something that is likely already in your textbook. What can we do about area and volume of irregular figures? And I suggest problem-solving activities. I have always advocated starting every math class except a test day with a short problem-solving activity of some kind. Maybe not problem-solving, maybe flashcards to help them review a specific set of algorithms or a way of solving a problem or math facts or something like that. But I'm very much a fan of starting class with some problem-solving activities. And so you could start with a problem for students to solve that involves estimating the area of an irregular figure drawn on a grid or graph paper. I'll show you some illustrations of that. They will look something like what students see on standardized tests and struggle with on standardized tests. But some simple problem solving involving those would help students to grasp the mental processes that they need for solving those problems. You could also help them to understand the volume of irregular figures using sugar cubes or unifix cubes. Now I have an illustration in front of me. I'm going to lift it up here to my camera so you can see this. I used sugar cubes, got them sitting on my little Green Bay Packers cup holder thing, so I don't get to see a reaction to that. But if I turn this around, you can see that I have a 2x2 cube with a single cube sitting on top of it. I used to think that sugar cubes might be a good thing to do this with. I've changed my mind because I have sugar all over my desk, and and the cubes are not really regularly shaped, so they're kind of hard to stack if you do more than a small figure. So you probably don't want to use sugar cubes. You might want to use unifix cubes or some other cube manipulative with your students. But I think most of you could look at that figure and you could answer the question, how many cubes are in that figure? And you would say, well, there are 9 cubes in that figure. Even if you could only see a part of it, you would say, well, it's 2x2 and it's a solid figure, so there are 8 in the main cube, and then there's 1 on the top, there's 9. But our students don't do very well on that. There's a step in that problem solving that they miss, and we miss problems like that in pretty significant numbers. And so some illustrations of that using cube manipulatives would be helpful for your students as well. What can we do about place value with understanding? Unifix cubes are a really good tool for that. It's one of their primary uses as a manipulative in education. If you're not familiar with them or with how to use them, just do a Google search on them and you will get hundreds of references. They're inexpensive. They're a really great manipulative for helping you to teach kids an understanding of place value. They can also be used to help you understand or to help you teach some things about volume to kids, so stacking them to represent figures of various shapes. Also, and I'll show you an illustration of this, you could have students shade squares in a grid to represent the value of decimal numbers. And that also is a very helpful exercise. What can we do about order of operations and symbols of inclusion? My favorite activity for this is the game 24. The website is right there at the bottom of your screen, 24game.com. If you're not familiar with 24, I'm going to show you a card, but I recommend it to you. This is an example of a 24 card. When you play 24, the result of combining the numbers on the card is always 24. And so when I played this with my students, as I did all the way through high school, and often a couple of times a week at the beginning of class, I would hold up a card. I would wait until one person said they had the answer. Everybody would be writing their answers on a piece of paper on their desk. When one person said they had their answer, I would count off 10 seconds. I would call time. And then I would have 2 or 3 students who had gotten an answer either demonstrate on the board or just tell us what they did to get that solution. To get the solution, you use the 4 operations. You add, subtract, multiply, and divide. You do them in any order, so kids learn about order of operations. And you can use any symbols of inclusion, so brackets, braces, parentheses, the numerator denominator lines to indicate division. So this one's pretty easy. You could just multiply. 4 times 3 is 12, times 2 is 24, times 1 is still 24. So you just multiply in order. And here's another illustration. I'm not going to give you the solution to that, but I recommend that to you strongly as a way of helping your kids to automate order of operations and symbols of inclusion in a way that they'll enjoy and can really significantly improve their understanding and skills in that area. What do we do about simple algebraic equations and models? Even that phrase sounds kind of scary, but I think the only answer to this is to provide some student practice with solving simple algebraic equations in one unknown and creating simple equations based on a model. Here's an illustration of a model. This is all they're talking about when they talk about an algebraic model. If I've given you this chart or model where of X and Y in the top illustration, you teach students how to create an algebraic equation from a model by looking at that model and saying, so what's the relationship between the X and the Y numbers? Well, every time if you add 2 to the X, you get the Y. There's the equation. Y is equal to X plus 2. There's the model and the algebraic equation that came from the model. In the bottom illustration, same question. What's the relationship between the X and the Y? Oh, if you multiply the X times 2, you get the Y. There's the equation. Y is always equal to 2 times the X. So at 4th, 5th, and 6th grade level on a standardized test, that's all they're looking for when they talk about algebraic equations and models. Here are a couple of resources before I show you some other illustrations and wrap this up. The lesson plans for data representation that I told you about are on the AACS website in the Convention Resources folder. If you want some websites for paper folding activities, for cubes, ucubed.org or instructables.com or dreme.stanford.edu. Good resources for all of those things. And then some general resources for lessons on almost any of these topics. Some information on mathforum.com, and then some easily implemented lesson plans on teacherspaidteachers.com. You'll generally pay just a few dollars, $3 to $5 for a lesson plan on the Teachers Pay Teachers website, but that might save you hours of preparation on your own, and so I recommend it to you. I want to share this illustration document then back to some of the things that we've already talked about, but this is an illustration of a symmetrical figure that can be used for paper folding. I found it just by Googling symmetrical figures, and I could have printed scores of them. So all you've got to do, you don't have to draw your own, you don't have to invent them, just do a Google search in an images search, perhaps, on symmetrical figures. And you'll get a figure like this. You can fold this paper then along lines of symmetry. There are several of them. And in doing that, you're teaching your students about symmetrical figures, lines of symmetry, helping them to understand the concept. The next slide is similar. It is a simpler symmetrical figure. The lines, two of the lines of symmetry are already drawn, but with paper folding, again, you could illustrate and help kids understand symmetrical figures and reflections from those illustrations. Here is an illustration of using a grid, graph, plane in order to demonstrate figures. And I'm also a fan of using a coordinate plane like this for beginning to teach these things to your kids. They won't really use that coordinate plane until they get up into junior high sometime, for the most part. But if they start getting exposed to it, they become accustomed to it. This time it's just an illustration of a reflected figure, and you could fold that paper to demonstrate the reflection for them. The next is using a coordinate plane again, and this is an illustration of a translated figure. The figure is just picked up and moved over. You can't, if you fold it, it doesn't work. But if you cut the paper and transpose it or translate it, you move the figure from one side of the line to the other. You didn't flip it across the line, but you picked it up and moved it across the line. That's the kind of language that they will use on a standardized achievement test with children of this age. This page is illustrations of irregular figures on graph paper. So these are the kinds of problem solving that you could have kids do at the beginning of a class. Maybe award a bonus point for a correct answer, or award a piece of candy for a correct answer in a certain period of time. But you're teaching kids not just to apply a formula, but then to reason past that to calculate the area of irregular figures. Again, our students don't do well on these on the Iowa assessment, and so some practice in them would benefit them, not just on the assessment. It's a good thought kind of skill, the ability to reason for problem solving in a simple way like this. And then the last page is an illustration of using a grid or a graph in order to represent the value of decimal numbers and fractions. So across our top line, those shaded figures, all 100 are shaded in the first figure, so that is a 1. And then 3 are shaded in the next figure, so that represents the number 1 and 3 100ths. The last figure is 2 and 45 100ths. And you could teach your kids to write those as fractions or decimals. Best to teach them both. Teach them to write them as fractions and then convert them to decimals. And again, our children don't do well on problems like that on the Iowa assessment, and so some experience with something like that would be beneficial to them. That wraps up. I hope that is thought-provoking and helpful to you. I wanted to share with you not just the areas where we need help, but some practical ways of approaching them. Don't forget about the lesson plans that are available on our website if you want to do something supplemental to your curriculum with the data display types that we talked about. Thanks for joining us as an activity with your group in the time that you have left. I would recommend to you that you take a few minutes to come up with a brief review game or activity that you can use in your classes involving one or more of these areas that, from your experience, you think are probably areas that need improvement for your students. You won't be able to really analyze that until you run the reports and do the analysis. But I encourage you to give some thought to problem solving and game activities that can be a help to your students. Thanks for your time.